Yeah. Mhm. Meeting, 2 hours meeting.
Sir, good evening, sir.
வணக்கம். ஒரு நிமிஷம்.
Titus sir, good evening.
Hello sir, good evening Samuel.
Samuel, good evening, good evening. Welcome.
How are you sir?
Oh, fine. Samuel, how about you?
Very fine, thank you.
Welcome.
Seeing you after a long time.
Yeah. After a long time, very long time. Titus sir, shall we start the program?
Yes, sir.
Yes, sir. Thank you. Happy good evening to everyone. Today we have an interesting topic that is about solar related topic, the basics of solar photovoltaic system and design. This is going to be delivered by an eminent professor, Dr. Titus, our professor from Department of EEE, K. Ramakrishnan College of Engineering, Tiruchirappalli. We welcome you, sir, for today's program. Thank you, sir, for accepting our program, for delivering your topic to our members today. Thank you so much. So we, Tiruchirappalli local center, we conduct regular weekly programs for the past 3 decades. After the pandemic, we switched to virtual mode. Now this is your 167th program today. And we is being done with all the professional body association, Trichy Complex. There is a safety and quality from New Delhi, Computers of India, Trichy chapter, Indian Institute of Building, Tiruchirappalli branch, Indian Institute of Metals, Tiruchirappalli branch, Indian Society of Non-District Testing, Tiruchirappalli branch, Indian Institute of Industry Engineering, Tiruchirappalli chapter, Kumari area, Paravai. With this, all the association today we are doing this program. So with this small, we are the role model to all our professional bodies to conduct weekly programs. And this is, as I told you, the 167 program in virtual mode. Now I call upon Engineer Lakshman, our past honorary secretary, as well as present committee member, to introduce the speaker, Dr. Titus, to the audience. Over to Mr. Lakshman. Lakshman, please.
Yes, sir.
Lakshman, yeah, please introduce us. Yeah.
Sir, welcome to all. Welcome to today's speaker. Introduction about the speaker. Profile. Name Dr. S. Titus. BE, ME, PhD, MASTE, SMIEEE, MAE. Designation Professor, Department Electrical and Electronics Engineering. Email Dr. S. Titus at gmail.com, Titus EEE at krce.ac.in. Dr. S. Titus, Professor in the Department of Electrical and Electronics Engineering and HOD for S&H Department at K. Ramakrishnan College of Engineering, Tiruchirappalli. He did his bachelor degree in Electrical and Electronics Engineering at Satyabama Engineering College, Chennai, and master's degree in Power Electronics and Devices at Shanmuga Engineering College, Tanjore. He pursued his Doctor of Philosophy in Power Systems Optimization at Anna University, Chennai, through Government College of Engineering, Coimbatore. His research interests are power electronics and drives, power systems optimization and renewable energy sources, wind and solar. He has good teaching experience, international and conferences, and conducted many AICTE funded research program in the field power electronics drives and wind energy and solar photovoltaic cells. He has received 2 AICTE funded MOD ROBS, 3 AICTE funded FDP projects, 1 CSIR and AICTE fund for conferences so far. He is a member in various professional bodies and societies like IE, ISTE, and senior member SMIEEE. In IEEE, he is a recognized supervisor of Anna University, produced 6 PhD research scholars and 6 more scholars are doing research under his supervision. is a convener for KRCE, IIC, and nodal officer for ARI IA ranking activities. Also recognized as one of the innovation ambassador in KRCE by Ministry of Education, New Delhi. Teaching experience 23 years, research experience 20 years, publication 38 papers in international journals, 31 papers in conferences, published 2 book chapters in Springer and Taylor Francis. Patent filed 3 patents, also organized conferences, workshops, and seminars more than 100. Guest lectures given more than 25. With this introduction, I request today's speaker to take this lecture program. Welcome, sir.
Okay, thank you, Mr. Lakshmanan, for a nice introduction of today's speaker. Now over to Dr. Titus, sir, for your presentation. Dr. Titus, sir, you can present, sir.
Yes, sir. Thank you, sir.
Yes, okay.
I'll share the screen, sir.
Yeah, please share the screen, sir. Rights are given to you, please share it.
It's clear, sir.
Yeah, make it full screen, sir. It is a PPT mode. Kindly make it full screen, sir. Yeah, okay, sir. Now it's full screen. You can start from here. Yeah.
Okay. Very good evening to one and all gathered here. Thank the IEI Tiruchirappalli. Sir, good evening, sir. Very good evening to one and all gathered here. So I take this opportunity and also thank for the opportunity given by the IEI Tiruchirappalli Local Center. So today the topic which we are going to discuss is the design of the standalone PV system and the basic concept for any PV systems. So we know that how the basic PV system is working. So through the sunlight, sun energy, energy from the sun due to radiation, the solar PV system was working. So from the solar PV system, we are taking the output and it is given to the charge controller. And then from the charge controller, it is given to the battery storage system. So from the charge controller, it can be given to the inverter so that we can use the domestic appliances, that is AC load. So here from charge controller to battery is a bidirectional power transfer. That means during the daytime, with the help of the sunlight, sun energy, we can store the energy to the battery. If there is no sunlight during the night hours, we can take the power from the storage system, from the battery to the inverter. So this is the basic concept for the PV system. So and also we know that the solar panel output can be given to the light. This is one application. The positive and negative terminal will be given to the light. And also, if you see the applications and the usage for the domestic appliances, we can take the power from the solar panel to the motor. And similarly, you can use the solar panel output for any electronic devices for charging a battery or charging a cell phone. So these are some of the applications. Similarly, the solar panel output can be used for the any load. And here in the bottom, we can show that the solar panel can be used for a table fan. Nowadays, the DC motor table fans are available. So the voltage and the current of the solar panel should match with the fan voltage and the current rating, means then we can directly use that panel to the using the solar fan. So these are all few applications which I am suggesting that. So if you want to use the solar panel for any home appliances or domestic applications, then what are all the things which we required? What are the basic fundamentals which we needed? And what is the subject, basic things, we at least we must know that. That is what I am going to discuss about today. Whenever we go for any solar panel applications or any design, what are the basic requirements we required, and what are the basic knowledge that any person should have whenever we go for this any design of the solar PV systems. So if you want to go for any applications, that is, if we see that if the solar panel output is going to be used for any load, we cannot use it directly. So in between that, there is another device which is called as a controller, which plays a major role. This controller is not only to control the load alone, it also controls the battery management system. So we can store the energy in terms of battery or in terms of electricity grid. If we going to use the battery, or it can be transferred through the electricity grid. The solar panel can be output can be used, and we can store the energy by two means with the help of the any controller circuit. Then how this various things are connected means, first we require, what are the things we require means, solar panel is required. Then we must need a controller circuit, and then we must need a load. Then for that, you need energy storage system. So this is the general basic setup that is already which I have shown in the previous slide. The controller can be this can be a bidirectional. So from the daytime it can be stores the energy, in the night time it can take the energy from the battery and then it is given to the load, or you can directly given to the energy storage to the grid. From the grid we can connect it to the load. So the next, these are all the four basic things which is required for any fundamental things. So how it is working means, how the storage medium is going to be plays a role. If the storage medium is we consider as a grid, then that solar system is a grid connected solar system. If the storage system medium is used as a battery, then the solar system is called as a off-grid solar system. That is called as standalone PV system. So for any standalone PV system, what are the basic things, knowledge we must have, we required? That is what which I am going to explain today. What are the fundamental things we must know for any basic standalone PV system? So if the storage medium is a grid means it is called as a grid connected. If you use the storage medium as a battery, then it is called as a standalone PV system. In case if the storage system medium will be both battery and the grid, if you are going to use both battery as well as the grid, then the solar system is called as a hybrid solar system. So basically, for any sizing of the solar PV system, these three things we need and we must have a knowledge. What is energy, what is the power, and what are the loads and the power ratings which we are going to use. So for what load, for what is the requirement of the power rating only, we need to select the panel, and also we need to select the other controller devices or battery, anything else. So we must have some knowledge on these things. So if you take the load details, for example, for any domestic application, for standalone PV system, see that these are all the basic loads we normally used in our homes. That is, we can use two lights, any light with a power rating of 12 watts. And then light 2 will be consist of a 15 watts. Similarly, if you are using fan 1 as a 60 watts and another fan load will be a 70 watts, television 74 watts, washing machine 320 watts, or laptop charger 10 watts. So we have to calculate the load details, that is the power which we are required. The total power which we are required here is approximately 561 watts means, then what will be the required of the solar panel and what will be the required of the battery and other things that we have to plan. So how to calculate the energy consumption of the load? So how much energy is that is the electricity is consumed by the load per day, that we can be defined in terms of power. So power is the capacity of the machine. We need to do some work, but energy means how much work that machine or the load can do. So that is the difference between the power and the energy. So if you consider an example for an LED light with a rating of 5 watts, then what will be the energy which we are required. So we know that the power into the duration of the usage. That is, power is defined by the unit watts and the duration of the usage for how much hours it is going to be used. That is in terms of hours. Therefore, the power which we are using is the LED light is 5 watts. Suppose if I am using that 5 watts LED for 5 hours per day means, so per day we need 25 watts hours per day. So similarly, the power into the duration of the hours is called as a energy, that is watt hour. So power watt into the usage of the time is in hours. That's why we defined the energy in terms of watt hour. That is basic things which we are required. So if you consider an example of LED with a power rating of 10 watts, then what is the energy consumption per day? So 10 watts into 10 hours per day means then 1000 watt hour per day. Then what will be the electrical consumption per month? If you calculate it for per day, similarly you can calculate for per month also. If per day 10 hours, if the 10 watt LED is going to be glow, then for 1 month what will be the total energy whatever consumption will be, that we have to calculate. So it will be 10 watts into 10 hours per day means multiplied by 30 days will need 30,000 watt hour per month. So like that,
3,000.
3,000 watt hour per month. So what is the energy? Similarly, you can calculate for the water heater also. Water heater energy consumption per day, if it is at 2,000 watts and it can be going to be used for 1 hour per day, then what will be the energy required every day? So like that, we can calculate for month also. So just multiplied by 30 days, you will get approximately 60,000 watt hour per month. So like that, for each load, we can calculate what is the energy required, and we can tabulate the usages. That is, as I shown already, what are the loads we are going to use and what is the rating of the load, that is in watts. Similarly, for how much hour we are going to use that, that is in terms of hour, it is also given. And also the next column is we have to calculate what is the energy consumption per day, so watt hour, and also for watt hour per month. So if you calculate the watt hour energy consumption for each load and also for for each month, for per month, you can know that what is the total energy consumed by the home appliances in day-to-day life. So these are all the basic requirements which we are required. Then I will come to that sizing of the PV array and the power rating and the cost. So if you want to if you want to calculate the load, what is the energy required and all those things, if you are calculated, then only we can go for that. What is the panel required, which we are required sizing. That is what is the rating of the solar panel, how much watts we are required, that we have to select. So we know that what is solar panel. It is a panel which generates the electricity based on the irradiance. Irradiance means based on the sunlight. So irradiance standard value test condition is 1000 watt peak hour. So that is our Indian standard. We have to take it as a 1000 watt peak. So how to specify that solar panel means only in terms of ratings of in watts only. So nowadays in a market, the solar panel are available in various power ratings like 1 watt, 5 watt, 10 watts, 50 watts, 100 watts, 250 watts, 300 watts, and 400 watts, etc. So based on our requirement, we need to select and we have to purchase the panel. So under standard test condition, as I told that the solar panel rating is given in watt peak. The standard value is the 1000 watt peak for solar irradiance. So these are all the terminologies we used, that is in the specification. In the back side of the panel, all these parameters will be mentioned. So the maximum power which is given by will be the P max. The voltage at the maximum power point is the V max. The current at the maximum power point is the I max, that is the maximum current. So the calculate the power, we know that the power P is equals to V into I. Voltage into the current will give you the power. So this is the example which I have shown, that the panel, solar panel specification, the back side of the solar panel, these parameters will be. So as a engineer, we must, if you want to go for any design, how to select the solar panel, how we can go for sizing of the panel, based on the specifications only we need to select the panel. So in the back side of the panel, these are the parameters which I have mentioned. See that in the bottom, the power P max, maximum the power rating of this panel can produce will be 40 watts. And the maximum voltage VMP will be 18.04 volt. And similarly, the current IM will be 2.2 amps. And the open circuit voltage VOC and IAC, this is the two important parameter. We must know that for any characteristic study of the PV panel. So VOC, open circuit voltage, for this particular panel is 21.8 volt, and the short circuit current will be 2.4 amps. And the minimum bypass diode and the series fuse, at present these are not required, but the above four, that is power, voltage, current, VMP, IMP, VOC and IAC is very much required. Apart from that, see that the electrical ratings also given here. The standard test condition which I have told for our for solar panel is 1000 watts watt peak or 1000 watts per meter square. And the air mass density will be 1.5 spectrum, and the standard temperature will be maintained the 25 degrees Celsius. So for all our test conditions, we are considering only the temperature of the panel will be 25 degree, and the standard test condition of the irradiance will be 1000. Because that cell temperature is one of the most important, because with respect to the temperature, the performance of the solar panel will be varies. So if you take panel specification for 40 watts, what we have seen in the previous slide, they have shown that the specification is 40 watts. So the maximum voltage will be given as 18 volt, and the maximum current is 2.2 volt, and the maximum power P max will be 40 watts. So a solar panel of 40 watt peak rating will produce a power at a maximum power point is PM is equals to VM, maximum voltage into maximum current. That is also, it is given 18 volt into 2.22. So maximum power, the peak power, maximum power what we can obtain from this solar panel is 39.6 watt. That is approximately 40 peak watts. So by the way, we can check that what is the power rating which is given in the panel. So apart from that, we must know the fill factor also of the solar panel. That is also one of the important parameter, because based on the fill factor, the solar panel ratings cost will also be varies. That most of them will don't know, they don't have knowledge on that. Because sometimes for example, if you go to the market and if you are going to purchase this 40 watts peak panel, for example, if I am telling that it is a 1000 rupees, the same 40 watts panel can be obtained by in some another shop for 600 to 700 rupees. But the output what will be the same, even though the power rating will be the same, the internally the fill factor will be varies. So due to that fill factor, the cost of the panel will also be varies. So similarly, this is for 100 watt peak, again the same how the specification will be given. Based on this specification only, we have to calculate the maximum peak which that particular panel can be produced. So next I am coming to the solar panel cost. What is the cost of the solar panel? The solar panel price will be given in terms of rupees only. That is based on per watt, or that is in dollar per watt. So per watt, how much the cost they will be calculated. The cost of the small solar panel will be 25 to 35 rupees, and for the larger panel it will be I think sorry, it is the value will be mistake, but actually for small solar panel it will be around 25 to 30 rupees only. So what is the solar panel technology, and what is the efficiency, and what is the area? This is also more important while we are going to design the go for any solar panel PV system. So if you go for panel, again, based on the technology, we have to select. We have monocrystalline solar panel, polycrystalline solar panel, silicon-based technology, and thin film-based technology. Like that, different variation of solar panels are available. Based on that requirement, we can go. If you go for silicon-based technology, again, multicrystalline silicon solar cell in a rectangular shape, and the thin film material size and the shape of the material will also be changes. And another one is the area. Area of the panel is another important parameter. If the size of the panel, this is the full cell. If you take only half cell, automatically the output performance will be changed. Similarly, if you take only quarter cell, again the output will be changed. That I will show you how it is in the next coming slides. So for the solar panel parameters, these are all the main parameters already, which I have shown that this is the VI characteristics of the solar panel. Based on the specification given in the solar panel, the ISC and VOC are more important. So based on that, this curve will be drawn. So VOC in the x-axis and ISC in the y-axis, short circuit current. So how to calculate the maximum power? Peak power means only if you know the maximum voltage VM and IM. Once if you know the maximum voltage VM, then it is easy to find out the IM. So how to find out this VM and IM means only with the help of the PV curve. From the PV curve, we can easily find out what is the maximum power. So these are all the parameters. Normally we used to take care of that in the solar PV system. Short circuit current ISC, open circuit voltage VOC, maximum power point Pmax, and the IM and VM, and also the fill factor and the efficiency. So there are 5 common operating condition or factors which affects the solar system, solar cell. What are the main 5 factors which affects the solar cell means? One is the conversion efficiency. Due to conversion efficiency, the solar cell performance, it will affect the power generated by the solar cell. And due to the amount of the light, that is called as Pin, the amount of the sunlight which we are receiving, irradiance. And then the solar cell area, size of the solar cell is then another important area. Then the angle at which the daylight falls, the angle of attack, the angle of the light which falls on the panel. So that is why we need to take care of that, the direction and the angle of the panel while we are going for installation in any places. Then another one is the 5th parameter is the operating temperature. This is also more important. In standard, we take it as a 25 degrees Celsius. So the conversion efficiency of the solar cell affects the power generated by the solar cell. How means? We know the formula, that is the efficiency is output by input, but in addition to that, the area of the panel is also required. So P output will be P in, that is the sunlight irradiance level, P in into the efficiency into the area. So for any manufacturers, whenever they go for solar panel manufacturing, they will decide that the efficiency of the panel. So once they decide the efficiency of the panel, we cannot change the efficiency of the panel even though the solar radiation is going to be increases. So the maximum, while designing itself, they will fix that what is the maximum efficiency that particular panel has to, they will produce. So once they fix the efficiency, we cannot change the efficiency of the panel. So that is why they are given some standard efficiency in the solar PV system. So efficiency of the solar cell is fixed and it cannot be changed. So if you know the input radiation P in standard condition 1000 watts per meter square means, and if they are given, or you can assume the cell area is 100 centimeter square means, then what will be the output power? So see here, the solar efficiency is given as 16%. Here it is fixed. The efficiency of the solar panel is 16%. And the daylight, that is P in. P in is given here, that is 100 watts per meter square irradiance. So efficiency is 16%. If the solar panel output is given to the watt meter, what will be the output power? For this 100 watt per meter square radiation on this sunlight falls on the cell with solar cell efficiency of 16%, you will get the output of 1.6 watts. That is what it is showing in the watt meter also. In case if the solar efficiency is reduced, if the panel, if I'm going to change the solar cell for 12% for with the same irradiance, 1000 watts per meter square, then you see that the output power is changed. That is, it is reduced from 1.6 watt peak to 1.2 watt peaks. The reason is this solar panel is, it may look similar. The size and the other things maybe look similar, but this panel is designed for 12% and this panel efficiency is designed for 16%, with assuming standard temperature of 25 degrees Celsius. The temperature also same, but see that due to the efficiency of the design, the output power of this panel is 1.6, whereas for 12%, the output panel will be 1.2 watt only, provided the input of the irradiance is constant. It's the same, 1000 watts per meter square. So, as the conversion efficiencies increases, output power of the solar cell will also be increases. So that is the takeaway here. If the efficiency is more, then the output power will be more. If the efficiency of the solar panel is less, then the output power will also be less. So change in the area of the solar cell will be equal to change in the power generated by the solar cell. How? So short circuit current for a given solar cell is always fixed or constant. Open circuit of the solar cell is determined by the band gap of the material. So if you assume the short circuit current is 35 milliamperes per centimeter square and the cell efficiency is 16%, and the input radiation P in from the sunlight is irradiance level is 1000 watts per meter square, means then you see that here in the panel, solar panel, 1000 watts per meter square is sunlight irradiance is fall, and the current output is showing that it is 3.5 amperes for the solar area of 100 centimeter square. So the next area, what we are going to see here is the solar area. Change in area of the solar cell will change the output power of the solar cell. Previously, I have explained that the efficiency, based on the efficiency, the output is changing. Now I am telling that based on the area of the solar cell, the output is going to be changes. So here, this is the specification. With this 16% efficiency and with the input radiation is 35, and the short circuit current will given 35 milliamperes per centimeter square, they given the output of 3.5 amperes. And the solar cell area which is given here is the 100 centimeter square. If the solar cell area is changes, then the output will also be changes. You see that the next diagram. Now I cut the solar cell into half. Here only the half of the solar panel will be taken. That means your solar cell area will be reduced. Previously it is 100 centimeter square. Now it is only 50 centimeter square. So see that with the same irradiance, 1000 watts per meter square, so due to the reduction in the area of the solar cell, size of the panel is reduced, the output of the panel will also be reduced. 1.75 amperes. So it means large solar cell area means high current, small solar cell area means low current. So if you want to increase the size of the panel, if you want to go for more panel, then your generation of the power will also be increases. So if you need more power, if you want to increase the generated power has to be more, then we have to go for more panel, that is in arrays or like that. So we have to add more number of arrays or strings. Then if you talk about the efficiency, again, the amount of the light or the irradiance is converted into electricity is defined as a solar efficiency. So for solar panel area, for specific area, they have defined that if it is a 15% efficiency, the output watt per meter square will be 150. If it is a 18% efficiency, the output watts per meter square will be 180. For silicon, the efficiency will be only 15 to 18%. For thin film, it will be somewhat, it is lesser than that of the silicon solar cells. It will be around 14 to 16%. So what is the power requirement? Based on that, we have to find out how much square feet size of the panel we required, based on the solar panel area. How to calculate the solar panel area and what is the power requirement? If the power requirement is 100 watts and they are given the panel efficiency 50%, means that may be give up to 150 watts per meter square. So from that we can calculate the solar panel area will be the 1000 by 150 watts per meter square will give approximately 6.66 meter square. So 1 square meter will be equal to 10.76 square feet, means then what will be the square feet for the 6.6 meter square? So for 6.6 square meter, we will get approximately 71 square feet or 72 square feet. So if you want 1 kilowatt, that is 1000 watts, minimum we need 72 square feet to generate that 1 kilowatt power. Similarly, if you want 2 kilowatt, then we need to go for 144 square feet. So like that, we have to decide the solar panel area. And the solar panel life is approximately 25 years. And if you talk about the maintenance, the cleaning of the solar panel should be regularly maintained without forming dust. Due to that, the performance of the panel output will may be reduced by various means. By it can be also they will target as a dead zone or some maximum power point tracking due to some dust or due to some unwanted material falls on that. Due to that also it will be changes. So for proper maintenance is required, and there is no moving part is in that solar panel, therefore less maintenance is required. So when I coming back to the battery, which is one of the most important thing in any solar panel design, and nowadays it is very, very important for EV application also. Everybody is more concerned about that, the performance of the battery. So whenever we talk about the battery, we are using battery in many applications for cell phone, laptop, and also for EV vehicles. So nowadays, this is a challenging area. So I want to throw some highlights on the regarding the related to the battery. So the battery is similar to a water tank. How much water that tank it can store? How much water can be stored in that tank? Similar to that, what will be the storage capacity of the battery will also to be considered. If the tank is having only 50% charge, or if the tank is having only 70%, or if the battery is going to be charged for 100%. And also we know that the battery will be in terms of the ampere hour. Already we have discussed about that. So battery charge capacity will be defined. If you want to go for any panel, any PV standalone design, or for PV solar photovoltaic systems, we must also should have a knowledge on the battery also. So whenever if you want to go for purchasing any battery, similarly what I have discussed so far is regarding the solar panel and the efficiency. Now I am coming back to the battery system. So why we are considering the ampere hour, means that is current with respect to hour only. We are going to talk about the battery. If the battery, how much current energy it can be stored, and for how much hour it is going to be delivered, that can be depends on the load also. So if you want to need for some specific application, how much hour we required that battery. That is why we are concerned about the current ampere as well as the ampere hour. So battery sizing is ampere hour. So batteries available in the market means 2 ampere hour, from a very low level to high level. It is nowadays it is available 2 ampere hour, 10 ampere hour, 50 ampere hour, like that. We can have so many batteries. Small batteries means in terms of milliampere hour, it is available. So small battery ratings means that is 1000 milliampere hour battery, 2000 milliampere hour battery, or 5000 milliampere hour batteries are available. If it is a 1000 milliampere hour battery, means 1 ampere hour, that is 2000 milliampere will be 2 ampere hour, or 5000 ampere will be 1 ampere hour. Then the battery terminal voltages. This is another important thing which we must know, that a battery consists of 2 terminals. One is the positive terminal and the negative terminal. So the terminal voltage is more important, and the charging capacity in terms of ampere hour is important. whenever we go for batteries in the market, we must know the terminal voltage, 2-volt battery or 4-volt battery or 6-volt battery, like that. So how much energy that the battery can store is a very important parameter which we need to require. The energy stored in the battery is the terminal voltage and the charge capacity. So energy stored in the battery will be calculated the product of the terminal voltage and the charge capacity, because everybody is worry about that how much energy that energy can store. So energy in the battery will be voltage into the charge capacity, that is in ampere hour, that is V into ampere hour. So finally V into A will be power and H will be our hours, therefore power into hour, therefore power unit is watt and hour is H, therefore we are defining the battery in terms of watt hour. That is the unit of the energy. So these are all some basic few examples that I think due to time, these are all basic things I can skip. So the content most required is the content. Some main thing is battery technology related to the battery. These things are more very important. What is the technology which we are going to use? Which type of technology? And what is the energy which we are going to extract from that battery? And what is the life of the battery? And what is the cost of the battery? And what is the maintenance of the battery is very much required whenever we go for battery selection. So if you talk about the battery technologies, what is the material which is used in the battery cell? So two commonly used batteries nowadays in the market, very well used is the lead acid battery, and another one is the lithium ion batteries. Nowadays, many researchers are going for non-lithium ion batteries. Many work are going for that, because battery has many challenging parameters like cost, weight, and the time of charging and discharging. Nowadays, for charging, everything is coming. So we need to worry much about the batteries nowadays. So the basic unit of the battery is the battery cell. So combining the cells together can make a battery pack and at a bigger size, similar to the panel. If you want more power, we have to add a number of panels. Similarly, if you want more output power from the battery, we need to connect more cells. So connecting 2 cells in series means we'll get 4 volt, 3 cells means 6 volt. If it is a 6 cells means then we will get 12 volt. So how many cells, what is the voltage we required? Based on that, the cells will be connected in the battery. So the lithium ion battery will give 3.7 volt. And if it is a LFP lithium battery, it will give 3.2 volt. So how much energy stored can be the stored energy can be utilized is the more important nowadays. So when we talk about, we concerned about the battery, the energy stored, the batteries are not fully utilized. In any battery, if you charge the battery for 100% means, it doesn't mean that we are, once if it is charge is getting down, it doesn't mean that it is totally, discharged, and we cannot also fully utilize that total charge in that battery. So that means the depth of discharge is the one of the important parameter we talk about the batteries, that is a percentage of the energy taken out from the battery. How much energy we are going to take out from that battery, how much energy we are going to utilize, that can be defined, or the terminology which is used is the depth of discharge. Nowadays, the battery is are more concerned about that fast charger and all those things. It means that future, that means it is talking about the C rate, that they'll talk about the C rate. C rate means how much fast that battery can charge and discharge. So in older days, we more concerned about only the discharging rate for C rate, but nowadays many EV applications are comes. We are more concerned about the rate state of charge as well as discharge. So depth of discharge means the rate of the depth of the discharge will be varies. For example, for lead acid battery, it is only 50%. Lithium ion battery means 80 to 19%. It means if as an engineer, we must know that what is the depth of the discharge. Mostly they won't give the specification. We will think about that it is an 100%. If the battery is 100%, but we can use it only the 50%. It means that the battery can discharge only up to 50%. After 50%, it will not be discharging any output. Similarly, for lithium battery, it can discharge only up to 80-90%. That is why nowadays we are more going for lithium batteries. The usage of the batteries are more lithium, since the depth of the discharge is higher when compared to the lead acid battery. So if the energy stored in the battery is 12 volt 100 ampere battery means, then the output will be 1200 watts, approximately 1.2 kilowatt hour. If the battery is designed for 50%, normally the lead acid battery will be 50% only. If the depth of discharge DOD is 50%, then only 600 watt hour of the stored energy can be taken out, or we can utilize out of from the battery of 1200 watts. If your battery is sizing, the rating is 1200 watts means you can take the output only 600 watts. That means in a lead acid battery, if the requirement of the power, the electricity is 1.2 kilowatt hour means the stored energy should be double. If you need 1.2 kilowatt hours, the stored energy should be double due to 50% of the DOD. So if you want 1.2 kilowatt means, then 1.2 into 2.4 kilowatt energy. That means your battery sizing should be 2.4 kilowatt energy if you require the output of 1.2 kilowatt. So DOD is one of the important parameters we have to take care of whenever we go for purchasing any battery. If you need the output of 600 watt hour means, then we need to select the battery of 1200 watts. Mostly the people, they won't tell about this, but we need to take care of that whenever we are going to select the battery. So, and another important caution is you cannot use the truck and the car battery for solar applications, since they have very low depth of discharge. So it is not advisable. Similarly, in case of lithium ion batteries, if you are going to use 11.1 volt for a 10 ampere hour, so total the battery will be 111 watt hour. But in case of the lithium battery, the depth of discharge DOD is approximately 80-90%. That means for 111 watt hour for 90%, means you can use up to 99.9 kilowatt hours power will be available. Whereas in lead acid battery, we can use it only half of this. That is approximately only 55 in that range, 50 to 55 only we can use it. But in lithium battery, the depth of discharge will be more. That is why we are more preferring the lithium ion batteries nowadays. Then we talk about the life. You must also know the life of the battery. If I going to purchase the battery, what will be the life? The life of the battery can be estimated based on the cycle, charging and the discharging cycle. For how many times I can charge and discharge that, based on that, the life of the battery can be decided. In case of the lead acid battery, it gives 800 to 1500 cycles. So normally the warranty period or the life cycle panel of the battery can be approximately 3 to 5 years for lead acid battery. In case of lithium ion battery, it can take up to 1200 to 2500 cycles. So it can prolong, it can go for up to 4 to 8 years, the lifespan for the lithium ion batteries. So next one of the important parameter is the cost. The battery cost is very, very important. That will be, again, the battery cost will be defined in terms of rupees per watt hour of the stored energy. So battery cost for the small size, that is in the range of 500 watt hour to 1000 or 1000 watt hour. In case of lead acid battery, it will be 8 to 10 rupees per watt for small size. If it is a lithium battery, for small size, it will be around 17 to 20 rupees per watt, the battery cost. Similarly, for large batteries, storage batteries for 5 kilowatt hour or 10 kilowatt hour, approximately 10,000 watt hour. If it is a lead acid battery, the cost will be 7 to 8 rupees per watt. In case of lithium ion battery, it is 13 to 16 rupees per watt. So if we need 3 kilowatt hour or 3000 watt hour of lead acid battery, and the cost is 7 rupees per watt, means then what will be the cost of the battery? So if you want to know the cost of the battery, you can take it that you must know the what is the output watt hour. If you put approximately 7 rupees, means then the battery cost will be around 21,000 rupees if you want to purchase the 3 kilowatt hour battery, lead acid battery. And one of the thing is, you must know that the battery cannot be kept in the too cool dry places, and also it should be away from the sunlight and heat. Then only the performance of the battery and the life cycle of the battery can be improved. So these are all some examples I can give. So another thing which I have told, that in a battery you must know what is C rate. So nowadays the technical engineers will talk about in terms of C rate only. What is C rate means? The rate at which the battery is going to be charged or discharged. For example, if you're charging at a C rate of 1C, means the battery is charged from 0 to 100% in 1 hour. So capacity, if the rating is defined as 1C, it means that the battery will be charged from 0 to 100% in 1 hour, and can be discharged for 1 hour. So in the below it is shown here. See, if it is 1C, means it is for 1 hour. That is why they are telling that is 1 hour. If it is 2C means it is for 30 minutes. That is half an hour only you can use it. 2C means, that means 60 seconds, 60 by 2. If you put 60 by 2, you will get 30 minutes. If you put 60 by 1, you will get for 1 hour. Similarly, if it is a 3C means 60 by 3, it is for 30 minutes. If it is for 4C, then again 60 by 4, you can get only for 50 minutes. So one thing you must know, should understand that if the C rating is increases, the time of the charge will be reduces. Fast charging. So for fast charger, the C rating will be increases. But the disadvantage is, if you are increasing the C rate, you can charge the battery fastly. Nowadays, for many cell phones, we are getting fast charger. If you go for a fast charger, the size of the charger will be increased. So instead of having a cell phone, we have to take care of, and we have to carry equal to another one phone. That is the charger. Similarly, if it is a C by 2, see that here it is taking 2 hours. In the left hand side, if the C rating is reduced, your time of the charging will be increases for slow charging. If you go for slow charging, then the battery size, your battery lifespan will be increases, and it will be improved. But it takes more time. So this is more important while we talk about, and while we are discussing about the EVs. So if you say this is the general calculation, if you go for 30C, it will take charging time of 2 minutes. That is 60 by 30 will be 2 minutes. If you go for 20C, C rating, 3 minutes. If you go for 10C, 60 minutes. If you calculate by 60 by 10, it is for 60 minutes. If you go for 1C, 60 by 1, that is 1 hour. Sometimes it may represent at 0.5C or C by 2. C by 2 means that is 60 by 0.5. You will get 120 minutes. 120 minutes means that is 2 hours. So like that you can calculate based on the C rating is based on the hour which is the battery is going to be charged and discharged. The time taken by the battery to charge and discharge will be defined or related in terms of C rating. So this is what which I have told, that what is the depth of discharge. This is the total tank. The blue color is the usable watt hour or ampere hour, which is called as a depth of discharge. Even though if a battery is charged fully, the amount of the charge which can be delivered or utilized, maximum voltage will be 14.3 volt in lead acid. But up to 10.8 volt only, the battery can discharge. So the total state of charge will be calculated. The total charge 100 minus the DOD will give you the state of charge. So depth of discharge and the state of charge will be very, very important. And the life cycle, the number of times the charging and discharging cycle is important, but this will be depends on the DOD. So if the DOD is increases high, then the life will be decreases. So this is what we have discussed in the previous slides. I think this is the general calculation for that previous one. So this is the thing which I want to tell, that the basic thing anybody should remember whenever we go for any basic design of the solar photovoltaic systems or any standalone PV system. So thank you. So that's all my content which I want to deliver today.
Thank you, Dr. Titus. It is an excellent presentation. You gave all the basics of solar power related things. Thank you so much. Now, participants, we open to participants for their questions. Participants can ask the doubts. That India is gone for renewable energy big way. Now, renewable energy in 1,74,530 megawatts as a date. Also, the solar power is around 63,303. Over the year, Government of India is trying to add a lot of solar power, renewable power and all. What is the plan for storage cost? From your telling, what is costing around 8 to 10 rupees through battery.
Yes,
what is the alternate for sir? We should go for alternate, cheapest storage, or we should go for alternate. In the daytime, we have solar power, wind power and all. The same power can be used by storage night or other time,
Yes, sir.
Sir.
Yes, sir. Challenging battery is one of the challenging area.
You can answer the screen, sir, so that people will be able to talk. So, please.
Hello, Titus, sir.
Sir.
Good evening. I got one question.
Yes, sir.
Yeah, my question I ask you, sir. Sir, let him answer my question. Then you ask your question.
Oh, you asked.
I already asked you one question. Sorry, it's going to answer. Yeah, please answer, sir. Then you can answer sir's question.
First, I'll answer the screen, sir.
Yeah, answer. So it will be easy. All the participants will be visible.
Hello.
Oh, yes, sir.
Hello, sir.
Yes, sir. Please answer. Yes,
sir. Battery is one of the challenging area nowadays. Storing the energy is also very difficult for a larger application. In daytime, we can store the energy. But in the daytime, we can utilize that energy, but not for a longer, big applications. So that is why we can also nowadays they were talking about that B2G and G2V concept also. That is, we can take the energy from the grid, also from the vehicle, and also vehicle to the grid.
Now over the years, now the Government of India is planning for more renewable towards zero emission. We are going for electrical vehicle. We are going for new energy vehicle and all. What is when we go for a big, there is what do you call generation of renewable power or the solar power or wind power. We should also enhance the capacity storage. But the costing of this battery cost is almost 1 unit is costing about 8 to 10 rupees. You are telling from your slides, sir. That's what I understood.
Yes,
it is costly. We go for government of thinking is big way for pumped storage. Pumped storage in the daytime, when renewable is there, they are going for pumped storage. So that we can daytime, nighttime we can pump the same thing, use it for the generation of the power.
Yes, sir. Battery is one of the very big issues. That is why the e-vehicles are not coming that much faster nowadays, because the battery is one of the difficult due to cost and also the charging and discharging timing and the charge station. All these things they are concerning, and that's why they're still working on for various other type of alternative batteries with cheaper cost and more charging and discharging time.
Right, sir. Thank you, sir. Dr. Karupusamy, sir, you can throw your question, sir. Please, sir. You are asking some questions, sir. Please, sir. Karupusamy, sir. Dr. Karupusamy, sir. Yes, sir.
I am available. Titus, sir.
Sir,
You told the charge of battery only 50% will be effective discharge.
yes, sir.
The balance charge will be there, but that effective functioning will not be there. Am I right, sir?
Yes, sir. Yes, sir. We cannot utilize that about that limit.
Whatever application we look for, that will not work for the 50% of the charge.
Yes, sir. Yes, sir.
50%.
Yes, sir. Yes, sir.
But
You are
the charge
correct.
will be available in the battery.
Battery, yes, it will be available. That is the minimum limit,
But
the cutoff limit.
it will not do the effective, the required function.
Yes, sir. We cannot utilize it.
Utilize.
Yes, sir.
That is my one basic clarification.
Okay, sir.
For that, battery and solar, everything is only 50%, sir. And efficiency, solar cell also, if you put 5 megawatt, only 15% only efficiency, you know.
Yes, sir. Yes, sir.
That we have to calculate accordingly. We have to put the capacity. We have to
Capacity
enhance
of the battery. Yes, sir.
battery or solar cell.
Yes, sir.
Both I am combining. Okay, thank you very much. You were able to attend only part of your program only due to some other preoccupation today.
Okay, sir. Okay, sir. No problem, sir. Thank you, sir.
Thank you. You have done, but you have done excellently, it seems.
Thank you, sir. Thank you.
Let's I have watched your presentation, sir. From that only I asked this.
Okay, sir. Thank you, sir.
Thank you. Excellent, sir. Thank you very much, sir.
Thank you, sir.
Other participants can throw their questions, otherwise we'll go to the next agenda. Sir, lot of appreciations, sir, for you. Titus, sir, you have got lot of appreciations.
Thank you, sir. Thank you.
I am Samuel.
Yes, sir.
Samuel, sir, please ask me.
It's a very nice presentation, very informative. It's a
Thank
good,
you, sir.
Many of us are benefited. Good.
Thank you, sir. Thank you so much, sir. Thank you.
Sir, what is the lifetime of a solar cell, sir? Solar panel? How long it will come, sir?
25 years, sir. Now they are giving only up to 25 years warranty, sir. But it will be slowly degrading, sir. Aging will be taken place inside the cell. The output efficiency of the performance of the cell will be slowly reduced, but maximum 25%, 25 years only they are giving guarantee, lifespan of the panel, solar panel.
Sir, there is a question in chat box, sir. There's why the panel cost is not reducing. This is asked by Deepak Damena.
Yes, sir.
Why
That
the
is
panel cost is not reducing? He's asking a question.
it is again that is due to the efficiency, sir. We are unable to produce higher efficiency nowadays. The research is still, they are trying to give more efficiency through the solar panel. That is why they are going for a thin film and other things, but still they are not achieving the expected level. But
when the solar capacity addition is more, the more production is there. Normally, when more production is there, the panel cost should come is not. That's what I think his question. When the production is more, when the more requirement is there, the cost should come down, is not.
No, sir. If production is more, it's okay, sir. But again, the investment cost, initial cost will be the more. Efficiency will be very less.
Right. Okay. So there was appreciation on Nafal Safi has told about nice lecture. What is about balance of system? One Aniruddha is asking, Engineer Aniruddha. What is about balance of system?
Balance
chat
of
box is there.
balance of system means, sir, I didn't get you, sir.
Oh, sir, Mr. Aniruddha, Engineer Aniruddha, you can just open your this. You can talk straightly. Engineer Aniruddha? Yeah, please talk to Sir Dr. Titus straight. He is not clear
Sir,
about
I
it.
didn't get it, sir. What is that?
Yeah, he is putting what is about balance of system. He has asked in the chat box. Okay, sir, there are a lot of appreciation. Nice lecture, sir, and great lecture by James. Sridhar Samum has, he has appreciated. Nice lecture. Thank you very much. So many appreciations for you, sir, in the chat box.
Thank you, sir. Thank you.
Sir, how about the flexible panels? It is coming out in that news. Is it available in commercial
Flexible panel means the thin film you are asking, sir.
Yeah.
Yeah, and that is also nowadays the many people are started using for that is for buildings, sir. For building walls, they are sticking that, and they are producing power during the sunlight by using that. Instead of going for a separate area for solar panel, they can utilize the building area for generating the power for that particular system.
Life
So,
is conventional panel.
sir,
Any idea about life of the
May I know
flexible?
the efficiency of solar cell, sir?
sir, I am not clear, sir.
Any idea about the life of flexible panels
Life of the flexible panel.
as compared to standard panels?
No, sir, I'm not sure about that life cycle panel of the flexible panel, sir. For normal general panel, solar panel, it is 25 years, sir.
Okay. Thank you.
Okay, sir.
Sir, what is the efficiency, sir, at present?
Sir, for a thin film, it is only roughly 15 to 16% in application side. In research level, we are getting up to 25%, sir. In laboratory level, we are getting 25, but in a production, in application side, field, we are getting only roughly around 16%. 16 to 20.
Silicon?
Yes, sir.
Silicon technology. What
Yes,
is the
silicon technology only.
Is there any other questions, sir? Otherwise, we'll move to the next agenda.
The efficiency of the panel to be improved.
Yes, sir.
The research on that, how much time it will take? If
So,
the,
efficiency, sir.
yes.
Sir, nowadays, instead of silicon, they are using perovskite material, various chemistry, the various chemicals. They are trying to bring that efficiency, sir. Still, they are trying only, but they are not achieving, sir.
How much time it will take approximately?
I think since the demand was very high, we are going for alternate energy sources. Definitely, more researches are going on this battery technology and solar technology, sir. I hope it will, approximately, I can say that it will take another 3 to 5 years minimum.
Okay, thank you, sir.
Okay, sir.
It is a very good sir, for you.
Okay, sir. Thank you, sir.
Pleasure, sir.
Thank you, sir. Thank you. Thank you so much.
I request Dr. Kevin R. Kumar to announce the next 6 program. Over to Dr. Kevin R. Kumar, our Honorary Secretary of Institutional Engineering Tiruchirappalli Local Center. Dr. Kevin? Dr. Kevin, I think you are there inside. I saw you. Dr. Kevin?
Sir, good evening, sir.
Yes, sir. Please announce the next 6 program, sir.
So, good evening to all, and heartful congratulations to our today's speaker, Dr. Titus, for delivering wonderful lecture program. And thank you, sir. And next week lecture program will be on 28th February 2023. The topic is a revisit to production design and manufacturing in the foreground of 3D printing technology. It is a session on Industry 4.0, and the speaker is Dr. M. Kandan, Professor in Charge, Innovation and Production Development Center, Francis Xavier Engineering College, Tirunelveli. I request the participants, the members, the council members and participants from various institutes to participate in this lecture program, and also invite your friends and colleagues to participate in this lecture program, and e-certificate will be issued to all the participants. Thank you, sir.
Thank you, Dr. Kevin, for announcing next week program. Also, congratulating our today's professor. Thank you so much. Now I call upon Engineer Suresh Kumar, Honorary Secretary, Indian Staff League, Trichy Branch, to propose vote of thanks. Over to Engineer Suresh Kumar.
Good evening to all of you, sir.
Good evening,
First of all, I would like to express my gratitude to the organizers of the IEI TLC Local Center for the opportunity to me to deliver the vote of thanks. Our first and foremost thanksgiving goes to the Almighty God, the creator of you and me, for what we have and what we don't have. Mr. R. Silvaraj, past chairman of IEI TLC Local Center, coordinating and organizing this webinar. He is a man blended with industrial experience and a good academic profile. He is organizing the events regularly. Our gratitude to you, sir. Mr. R. Silvaraj, today he has delivered the welcome address. I record our sincere gratitude to you, sir. And Mr. Lakshmanan, past secretary of IEI TLC Center, introduce the today's speaker. Dr. Titan College of Engineering today is a speaker, and he's delivered the lecture about the basics of solar photovoltaic system design. He is a person speaks constructive words and do many wonders. I express our sincere thanks to you, Dr. Titus, sir, for your stewardship, support, vision, and commitment. And I would like to thank all the participants of today's programs. Regularly you are supporting us. And thanks to all the professional bodies and members. Thank you, sir.
Thank you, Engineer Suresh Kumar, for an excellent vote of thanks. Thank you so much. Good evening to everyone. Thank you for with your permission. We call up the day. And feedback form is link is posted on the chat box. I ask the participants whomever is interested to get the e-certificate, they can fill the form that you will get your e-certificate in your inbox, your mail inbox. Thank you, Dr. Titus, for an excellent show today. Really, it was very much interesting. We could learn a lot from you, from the basics of solar and power generation. Really, we enjoyed the lecture. Thank you so much, sir.
Thank you, sir. Thank you. Thank you, sir.
Yes, sir. Good evening. Good evening. Thank you. With your permission, we'll call up the day, sir. Thank you. Other participants whomever is interested, they can...
Samuel, sir. Thank you, sir.
Yes, sir.
Thank you, one and all.
Thank you, Samuel. Thank you. We are seeing after a long time. Thank you so much. Please come join for all the weeks. We are very happy to see you. Yes. Thank you, Dr. Manawalan. Dr. Manawalan also thanked a lot. Thank you so much. Dear participants, kindly fill the feedback link that will be available another 10 minutes only, another 10 to 15 minutes only. By 19:05, we will close the thing. We will close the link. That's what. Kindly fill it. You will get it. Get the e-certificate in your inbox, mail inbox.
Thank you, Past Chairman, Mr. R. Silvaraj.
Yes, sir. Yes, sir. Thank you, sir. Thank you for participation. For appreciation and all. Thank you so much, sir. Dr. Manawalan, thank you.
Thank you. Thank you.
The participants can also copy the certificate link.
When will you get the link, sir?
It is available in the chat box, sir. You can copy paste it so that it can use it for suppose we are not able to get the link or internet connectivity is poor. Now you can copy that. And if there is any issue in getting the certificate, you can try after some time using this link. So that is why I am suggesting this method.
Okay. Sir, let me leave the meeting. ஹலோ
சார் சொல்லுங்க சார்.
சார் இந்த இ சர்டிஃபிகேட் லிங்க் கிடைக்கல சார், அதை எப்படி பார்க்குறது சார்?
இல்ல சார், நான் இப்போ உங்களுக்கு இண்டிவிஜுவலா போட்டு ஓப்பன் ஆகுது.
இண்டிவிஜுவலா அனுப்புறீங்களா?
ஆமா சார், இதை கிளிக் பண்ணுங்க சார்.
ஆ?
இப்போ ஒரு லிங்க் சென்ட் பண்ணிக்க பாருங்க, லிங்க் ஒன்று சென்ட் பண்ணிக்க பாருங்க, அதை கிளிக் பண்ணுங்க சார்.
கிளிக் பண்ணிட்டேன் சார்.
ஃபர்ஸ்ட் ஃபார் இமெயிலில் வந்து உங்க நேம் கொடுங்க சார், உங்க இமெயில் ஐடி கொடுங்க சார்.
ம்
அடுத்து உங்க ஃபுல் நேம் கொடுங்க சார்.
இமெயில் ஐடி ஒரு நிமிஷம் சார். பேர் கொடுத்தாச்சு சார்.
சார்
சர்டிஃபிகேட்
அடுத்து ப்ளூ கலர் கொடுங்க சார். வாட் இஸ் த கலர்? இது கலர் ஸ்கை வந்து ப்ளூ கொடுங்க சார்.
ப்ளூவா?
சப்மிட் கொடுங்க சார். ஆமா, சப்மிட் கொடுத்துட்டீங்களா சார்?
கொடுத்துட்டேன் சார்.
ஓகே சார், உங்க மெயிலை ரீஃப்ரெஷ் பண்ணி பாருங்க சார், உங்களுக்கு ஆட்டோமேட்டிக்கா வந்துருக்கும்.
சரி சரி, ஓகே சார், ஓகே சார், தேங்க்யூ.
ஓகே சார், தேங்க்யூ சார். சார் ப்ரோக்ராம் க்ளோஸ் பண்ணுவா சார்? செல்வராஜ் சார்.